A very warm welcome. We are Team Data Nirvana, and our problem statement is AI-driven unified data platform for oceanographic, fisheries, and molecular biodiversity insights. Imagine that you are a researcher. You want to understand the impact of temperature and climate on a certain species in the Arabian Sea. For this, you go through different types of website and you understand that there is more and more data and in different file formats than you can understand. You try to understand this data, you try to go through this particular data standardization processes, and at the end, 80% of your time is went into data and only 20% of your actual time is into your research. I am a student. I want to develop a particular solution for marine intelligence. However, my main focus has been diverted because I have to handle data more than I can understand and process. I also have to go through multiple different types of websites just to store my original data. Someone else is an innovator. They do not understand a single thing about data. Their main focus is to create a solution for blue economy, which contributes to 4% of total GDP of our country. However, since they do not know much about data, they are not able to feasibly work with different multi-diverse data sets which are present. If you look at it, the problem here is very clear. You, me, and our innovator, we all are facing a data slack problem. Our data that is present is multi-diverse. It is in multimodal file format. There is no standardization that exists. And even after all these factors are present, it is not well defined. So what are we going to do regarding it? We are creating a unified data platform where all these different types of data sets are standardized, their particular values are made understandable, they are ready for research and for student orientation purposes, and they are easily accessible. But what if I told you that this is not the end? We are elevating it by a level by creating India's first AI powered marine intelligence engine, and that is our Ocean IO. Now, how are we doing this? Multi-diverse datasets exist. The main focus here is to understand the pain point of our users. Since we understand that data is different and we need to work on it, what we are doing is we are creating a data pipeline. Pipeline including OBIS, INCOIS, NIO, and then satellite-based data where data can be ingested in a seamless format. Otolith, which is the fish bone, is a standardized process used by researchers to identify the family and the species of a fish. Current datasets accept these particular otolith values and then, based upon their system, retrieve the matched value. What we are doing is, instead of going through that process, we created a hierarchical CNN model where you can upload any otolith image and it will give you a proper understanding of what particular species of that fish is and a 3D visualization of that particular species. All of this data in the form of Airflow pipeline goes in our data storage and DB. The data is standardized and stored in Postgre. The raw data files, which might be required by some people, is stored in MiniIO, and the vector embeddings for efficient query retrieval is stored in ChromaDB. All of these are then containerized and orchestrated using Docker and Kubernetes. They are connected with the help of Fast API to a React.js website, bringing to life the unified data portal, which acts as a data warehouse. The features of this portal include a dashboard where you can understand and actually view the impact that is present, a PPR and education hub which is oriented towards researchers and students to enhance their particular process of understanding the oceanographic data, and API and Docker for letting this particular scalability prove a further impact. The technical stack that we are focusing upon is React.js and Leaflet in the front end, Fast API and Redis in the back end, and the infrastructure of Docker, Kubernetes, and Airflow. But instead of explaining through the graph, let me actually take you to our Ocean.io portal. Welcome to Ocean.io. a unified platform for real-time ocean data, biodiversity insights, and sustainable marine research. I will take you to the data portal. This is a unified data portal. What it actually does is that, as I mentioned before, the multi-diverse datasets from hundreds of different websites are being stored here in a standardized format. It contains oceanographic data consisting of salinity, temperature, pH, oxygen levels that are present, measured by buoys through different sectors of our Indian Ocean. It consists of biodiversity data capturing the richness of marine life, focusing upon the species that are present, the biodiversity in a certain region, and how these particular species cluster in a certain group. There is eDNA dataset, which is nothing but traits of genetic traces collected from the shore level of a particular sea. Then there is a otolith dataset, which is nothing but the fish bones used to classify the species of a certain fish. These particular data sets are being stored in a singular format, but that is not all. We are able to classify these particular data sets on the basis of their species and their habitats by developing relational database models between all these data sets, linking them together with each other based upon the AFIA ID from the Darwin core system. We also have an upload dataset option for all the individuals or researchers who are present because these are the people who are actually working towards it. A query retrieval system is also present. The main aim of the query and the retrieval system is searching and retrieving species records which are there. Then there is data modeling, where instead of having to work in a different environment, you can actually connect a subset of your required data set, and then you can work upon these particular data as per your requirement. This is the oceanographic dashboard. Once we have all our data in our place, we are linking this data with satellite data from Copernicus and Sentinel-L1 radar. Then, on the basis of these two combinations, we are creating and bringing to life an oceanographic dashboard. It contains these following factors. It contains the chlorophyll factor, which actually is nothing but the vegetation in a certain region. Vegetation is important because understanding a type of marine species dependent on that specific vegetation, you are able to map what in a particular region the species can be accumulated. Temperature here plays another role. Temperature, including surface temperature of the ocean, the maximum temperature and the minimum temperature that faces in a particular day, and their impact upon biodiversity. Salinity of a certain region is also taken into consideration. Oceanographic current here is another important factor, as temperature and current together are the key drivers for a certain biodiversity region. Wind is another factor which associates and is also taken here into a part, and biodiversity mapping will always be present on the basis of these factors, especially in the times of migration. Then there is biomass which is present as well. And that is not it. After the mapping perspective, we also have an analytical dashboard where actual analytics is also being shown. Here, you are able to understand the parameter trends that are present, the forecasting and the anomaly metrics, and based upon a time series data, you can understand how this particular series occur as we move through time. So, a current prediction is also being done, and a future prediction is also being done. We will now move on to the next part. This is PPR and education, or policy planning, research and education. Here, we are accumulating the on ensuring that we stay within the governmental policies. We are ensuring that documentation is properly provided, and then we are also providing a built-in Jupyter coding environment. The main purpose of this coding environment is to ensure that irrespective of your particular work or your task, rather than having to go to your local IDE and then working there, you can actually just directly import the data that is present upon your portal and then the results can then be exported to your own device, reducing your own hassle. Another factor here is the API hub, which is nothing but our particular extension. Here, well-documented APIs will be provided for further research, applications, and innovations, ensuring that our solution is scalable and sustainable. And the actual marine intelligence engine can be also accessed in terms of its query retrieval and search engine. This is our data portal, query-based retrieval engine. Here, we are able to understand, based upon a certain species, the details that are present based on our relational database. Then, if any species image is uploaded, we are able to recognize that image, and then you are also able to understand its own details, including its scientific name and everything. And then, on the basis of otolith, you are able to classify what kind of species is it based upon our hierarchical CNN model and our neural network models. Now we will understand the feasibility and viability of our solution. In terms of feasibility, regulatory forecasting is one thing being considered because we have to ensure readiness despite the operational challenges that we might face. The data curation that is present should also include a manual factor. However, the data processing should stay automated so that data is always handled efficiently. The data ingestion pipelines have to be streamlined so that we have improving feasibility and at the same time the entire system becomes more robust. Viability includes ROI employment so that through better planning and yielding predictions, we can focus upon enhancing economic returns. This is more direct with the blue economy since it contributes 4% to the GDP of our country and emphasizes sustainable exploitation for long-term value creation. Stakeholder engagement is another factor since we are developing role-based APIs so we can broaden our adoption among different types of stakeholders. AI-powered analytics is the core of this engine so that advanced analysis and hypothesis exploration can be more feasible and can be more in terms of understanding. The key challenges is very simple that data which is present is not in a standard format and it is not at standard sources. Also, it is not directly available because multiple times we have to connect with the people at the website or we have to connect with the people at the organization for the request of the data. This is a key challenge which we are facing, and the mitigation is simple. We are working towards a system where it is open access, where it is easy to understand, where we are complying with all the legal policies and ensuring that our system is in a complete loop with whatever happening in the oceanic world. So our impact includes a unified marine data architecture connecting multidisciplinary datasets. Then AI-driven taxonomy and eDNA, which enhance our accuracy. We have simulations of climate change and impact modeling upon biodiversity, which is a part of our dashboards. And we are empowering our communities with visualizations, blending traditional knowledge and scientific data together. The benefits include ingestion of these particular data so that standardization is present and query retrieval is easy. Our interactive visualization tools through which the complex oceanographic and biodiversity trends can be made into actionable insights for researchers. APIs are present so that reproducible research is there and adoption across disciplines is existing. And we are also helping to track endangered species with the help of our satellite data and other data that is collected from buoys across the coast of Indian region so that we can contribute effectively to SDGs like SDG 14, Life Below Water. The scalability in this particular solution is ensuring that we move towards marine spatial planning, identifying conservation, harvest, and industrial zones. At the same time, we have to ensure mechanisms to make sure that inconsistency risks are mitigated and we improve the trust in our solution. Now, what is the actual market gap analysis? The unified data backbone that is present in the current market consists of limited datasets integration, meaning that datasets exist in bulk forms. However, these data are not integrated together with each other. We are creating a cloud platform which is modularly standardizing all the datasets into a single system. There is API and interoperability, but the APIs are closed or they are limited for specific data, as in the case of OBIS. So what we are doing, we are creating an open API so that all the global standards are implemented and data is easily accessible. At the same time, the biodiversity mapping is static. However, we are moving towards an approach where real-time, predictive, and multi-parameter approaches can be considered. We're also considering climate, we're also considering temperature, we are considering wind currents, we are considering surface temperature, and we are also laying our focus towards anomalogical events that occur in the ocean which may affect biodiversity, such as oil spillage and oil leakages as well. So, to conclude, Ocean.io is not just a data platform, it can be something much bigger than that. This has the potential to become the India's first marine intelligence engine, and the implementation that is done in this particular solution will work towards creating a sustainable life and a sustainable oceanographic background. Thank you.